we're going to tackle one of the most classic questions out there. Why is the sky blue? It's something we've all wondered about since we were kids. And the answer is actually this incredible window into the science of the very air we breathe.
All right, let's just dive right in. We all look up, we see this huge expanse of blue. But what is actually happening up there to make it that color? Well, the answer doesn't start in the sky. It actually starts with the sun.
So, first things first, let's bust a myth that almost all of us believe. You know how we always draw the sun with a yellow crayon? Well, our sun is actually a white star. The light that it beams down in the middle of the day is pure white. That yellow color we think we see, that's just a trick our own atmosphere plays on us. We're going to unpack that.
Okay, so you probably remember this from science class, right? You take a prism, you shine a beam of white light through it, and it splits into all the colors of the rainbow. Red, orange, yellow, green, blue, indigo, violet. Well, hang on to that thought, because our atmosphere basically acts like a giant, messy prism.
So that brings us to the next piece of this puzzle, the atmosphere itself. Because it's not just empty space up there. Nope, it's this incredibly complex filter that sunlight has to pass through.
Now, the air all around us, what we're breathing right now, it's mostly nitrogen, a good chunk of oxygen, but look at that little 1% slice. That tiny sliver of other gases and particles, that is where the real secret is hiding.
In that little 1%, you've got all sorts of tiny, invisible stuff floating around. We're talking about specks of dust, pollen, bits of pollution, little droplets of water vapor, just countless tiny particles. And these little specks are absolutely crucial for making our sky blue.
And this is it. We're getting to the heart of the matter. The core scientific idea that explains not just why the sky is blue, but also why sunsets are red. It's all about scattering.
So, there's a fancy scientific name for this. It's called Rayleigh scattering. But you don't need to remember the name. All it really means is this. It's what happens when light bumps into particles that are smaller than its own wavelength. And it turns out, not all light waves are the same size. Just think of the different colors of light as waves traveling through space. Red light travels in these long, lazy, stretched-out waves. But blue light, it travels in much shorter, choppier, almost bouncier waves. And that difference right there, that is the whole key. So remember all those little particles of dust and water floating around in the air? Well, it just so happens they are the absolute perfect size to get in the way of those short, bouncy blue light waves. The long red waves, they mostly just glide right past. But the blue waves crash right into these particles and get bounced all over the place.
And here's where it all comes together. As that white sunlight streams through the atmosphere, the blue light hits all those particles and gets scattered in every single direction. Up, down, sideways, you name it. It's this scattered blue light, coming at your eyes from all over the sky, that makes the whole dome above us look blue.
Okay, so once you get this idea of scattering, a whole bunch of other things suddenly start to make sense. And it explains some of the most beautiful sights in nature, starting with a good sunset.
Think about it. When the sun is high in the sky at noon, its light is taking a pretty direct, short path down to you. But when the sun is setting on the horizon, its light has to travel sideways through a much, much thicker slice of the atmosphere to get to your eyes.
So what happens when light travels through more atmosphere? Well, more atmosphere means more particles, and more particles means, you got it, a lot more scattering. By the time that sunlight reaches you during a sunset, almost all of that shortwave blue light has been scattered away, bounced off in other directions before it can even get to you.
So after that super long journey through the sunset atmosphere, pretty much all the blue light is gone. So what's left to actually make it to your eyes? Only the longer wavelengths, those beautiful reds, oranges, and yellows that paint the sky.
Here's another cool consequence of that same exact scattered light. The stars are still up there during the day, right? So why do they just vanish? It's not just because the sun is bright. This is the real reason. That scattered blue light doesn't just give the sky its color, it actually makes the entire atmosphere glow. You can think of it like the whole sky is a giant, glowing, blue lampshade that gets switched on every morning.
And that blue glow from our own atmosphere is simply brighter than the tiny, faint pinpricks of light coming from distant stars. It's kind of like trying to see a single candle from across a football stadium when all the giant floodlights are on. The stars are there, they're just completely washed out.
And finally, let's just step back and put all of this into perspective. Because understanding why our sky is blue, it also reveals something really profound and, honestly, a little bit startling about our home planet.
So how high up would you have to go for that blue sky to end? Well, the official edge of space is generally considered to be about 100 kilometers, or 62 miles straight up. That's the point where the air gets so thin that there aren't enough particles to scatter the blue light anymore. You cross that line and the sky just snaps to black, and you can see the stars, even with the sun out.
This just shows you how incredibly little atmosphere we actually have. There's this famous analogy that puts it perfectly. If the planet Earth were the size of an apple, our entire atmosphere, everything that makes the sky blue, everything we need to live, would be no thicker than the skin of that apple.
Just think about that. All of it. The scattering of light, the blue skies, the red sunsets, the very air that we are breathing right now. It all happens in that impossibly thin, fragile layer. It's a pretty powerful thought.
So the next time you look up at that vast blue sky, just remember the delicate dance of physics that makes it all possible, and the incredible fragility of that thin blue line that protects every single one of us. It makes you wonder, doesn't it? What does it really mean to live under such a beautiful but fragile shield?